Hi, today we're looking at Functional Skills Maths Level 2. This is the Open Awards exam board and we're going to start with the non-calculator section. Section A, Task 1. Question 1. The table below shows the distances walked by J each day in a week. We've got the day of the week, so we've got Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And we've got the distance walked, 1.5 miles, 3/4 of a mile, half a mile, third of a mile, third of a mile, 3/4 of a mile, and 0 miles on Sunday. What was the total distance J walked over the whole week? Show your calculations and the workings out here. Okay, so let's move this up a little bit so we've got some more space. Okay, right, so I'm going to actually write these out. So we want to add these all up. We want the total distance. Well, because I've got a mixed number here, I've got sort of a 1.5, so I'm going to split them. So I've got 1, then I've got a half a mile, then I've got a 3/4 of a mile, then I've got another half a mile, then we've got a third of a mile, another third of a mile, and then 3/4 of a mile. And 0, well, that's just 0. We can leave that off. Right, well, what we could do to add up the fractions is we could get a common denominator, because at the moment we've got different denominators here. But before I do that, I'm going to think, well, actually, is there a way I can match some of these together? So, for example, well, I know that a half and a half, well, that's going to be 2 halves, which is just 1. Okay, so we've already got a whole 1 here. We've got another whole 1 from these 2 halves. Well, my thirds, I've got a third and a third. So if I put those together, that's going to make 2 thirds. Might not have helped too much, but it's combined 2 things into 1. And we've got 3/4 plus another 3/4. Okay. Well, if we think 3/4 plus 3/4, that's going to give me 6/4. Right, well, actually, we can simplify 6/4. Well, they're both even numbers, so we can divide them by 2. 6 divided by 2 is 3, and 4 divided by 2 is 2. So we've got 3/2, or 3 halves. Well, now let's turn that into a mixed number. Well, 3 halves, that means we've got 1 whole and an extra half left over. Okay, so if we put this all together, what we've actually got is we've got 1 there, 2, another whole, so we've got 3 whole, which we can put down here, and then we've got this half, and we've got 2 thirds. Okay, so if we can combine these 2 together, then we can work out what the total distance is. So, as I say, we've gone from 1, 2, 3, 4, 5, 6, 7 things down to 3 things. And the only thing that we need to do is this bit here, which will be the hard bit. Okay, so we want a half plus 2 thirds. Half plus 2 thirds. Now we want to get a common denominator, because to add fractions, we need the denominator, the bottom number, to be the same. Well, 2 doesn't go into 3, so that means we're going to have to change the denominator of both of them. Well, what number does 2 and 3 go into? Or what's a small number they both go into? Well, if we do 2 times 3, then that means the denominator is definitely going to be a multiple of 2 and 3. So 2 times 3 gives us 6. So that means that we can rewrite this fraction as being over 6. And we can also rewrite this fraction as being over 6. Right, well, if you think to get from 2 to 6, we're multiplying by 3. So we're going to have to do exactly the same to the numerator, the top number. 1 times 3 is 3. So all we've done is we've rewritten a half as 3/6. Okay, now we're going to do the same with our thirds. Well, this time to get from 3 to 6, we're doubling the 3. So in other words, we're multiplying it by 2. 3 times 2 gives us 6. So if we want to keep this fraction still the same value as 2/3, we've got to do the same to this top number. So the 3 we multiply by 2 to get 6. So the 2 we multiply by 2, which gives us 4. So we've got 3/6 plus 4/6. Well, the answer is still going to be 6. 3 plus 4 is 7. Well, we want to get rid of this mixed, or this improper fraction and turn it into a mixed fraction or mixed number. How many times does 6 go into 7? Well, it goes once with 1 left over. So 7/6 is the same as 1 whole plus 1/6. So we can rewrite this thing over here. So 3 plus a half plus 2/3 is the same as 3 plus 1 and then plus our 6th. Or in other words, it's going to be 3 plus 1 is 4 and 1/6, which we can write in here. Question 2. Put these fractions in order of size, smallest to largest. Right, okay. Again, we could give these all the same common denominator, but instead we can maybe do a bit of comparison. So I've got 2 improper fractions here. And by improper fraction, I mean where the top number is bigger than the bottom number. So this and this, I know that the answer must be more than 1. So these are going to be my 2 larger numbers. These, the top number is smaller than the bottom, so these are all going to be less than 1. Okay, so these are going to be greater than 1, and these ones are all going to be less than 1. So instead of working all of them out together, I'm sort of splitting them into 2 groups. These are both eighths, so I can clearly see that 3/8 is less than 5/8. Well, what about the 3/4? Well, maybe if we can turn this into eighths as well, because I can see, well, to get from 4 to 8, I'm going to multiply by 2. So if I multiply the top by 2 as well, I've now got 6/8. So these 3 are quite easy to order. 3/8 is clearly going to be my smallest one. Then it's going to be my 5/8. And then my 6/8, which actually they've given us as 3/4. So all I need to work out is which is bigger, 4/3 or 7/6. Well, we want to get the same denominator now. Well, to get from 3 to 6, you're doubling it. So you're multiplying by 2. So 3 times 2 is 6. We do the same to the top number to keep the value the same. 4 times 2 is 8. So we've got 8/6 and 7/6. Well, 7 is less than 8, so that comes next. And then 8/6, but we go with the format they gave us originally, which is 4/3. And we would write that in here, but I'm just going to leave it up there for us. Okay. On to question 3. Calculate 273,696 divided by 24. Okay, well, first thing I'm going to do is I'm going to count back 1, 2, 3 and put a comma in there. So we've got 273,696 divided by 24. Well, I'm just going to do it using the bus stop method. So 273,696 goes inside the bus stop. 24 goes on the outside. Now, at first you might think, 24 going into a number, that's going to be quite tricky, but let's have a look and see. So does 24 go into 2? No, it doesn't. So what about 24 into 27? Well, yes, 24 is less than 27, and it's only 25, 26, 27, so it's only 3 numbers smaller. So it goes in once, remainder 3. Well, how many times does 24 go into 33? Well, it's going to go in once, and then we can just count up to 33. So 25, 26, 27, 28, 29, 30, 31, 32, 33. So that's 9. So it goes once, remainder 9. So how many times does 24 go into 96? Well, what we can do is we can try adding up our 24s. Well, what about 24 plus 24? 4 plus 4 is 8. 2 plus 2 is 4. Okay, so that's 2 lots. Let's add another 24 on. 8 plus 4 is 12. 2 carry them on. 4 plus 2 is 6, plus 1 is 7. Right, well, we're not up to 96 yet. So let's add on another 24. 2 plus 4 is 6. 7 plus 2 is 9. Right, so it goes in exactly, so it's once, twice, 3, 4 times. Okay, brilliant. Now we want 24 into 9. Well, 24 can't go into 9, so we put a 0. But we carry the 9 across. 24 into 96. Well, we've already done that. We know the answer is 4. So the answer we need to put down in this box is 11,404. Question 4. Calculate the surface area of a cube when the length of a side A equals 15 centimetres. Right, and we're told the surface area equals 6a squared. Okay, right. Right, so basically we're trying to work out what the surface area is, but we need to sort of work out what our A is as well, possibly. So let's think of this. We've got a cube. What if a cube is going to look something like this, and each of the sides is 15 centimetres. So 15 centimetres that way, 15 centimetres that way, and 15 centimetres that way. Okay. Now, if you think the surface area, well, a cube, we can split it up like this, if you want to draw the net of it. Or basically you can think, well, it's going to be a square where each side is 15 centimetres. And we've got 1, 2, 3, 4, 5, 6 faces. Okay, so we've got, in fact, I mean, they've told us it really. So we've got the area of a square is going to be 15 times 15. And then we've got 6 of them. Okay. Right, so we need to multiply these 3 numbers together. We've got to decide which order should we multiply them together. Now, a bit of it is personal choice, but you also want to think, well, what numbers are going to give me a nice round number to start with? So we could do the 6 times 15 and then multiply it by 15. I'm actually going to go do the 15 times 15 first, because I'm thinking that then multiplying a number by 6 might be slightly easier. So you can try it whichever way you want, but we'll do 15 times 15 to start with. Okay, I'm going to do it by using the column method, but we're actually going to do it a different way afterwards as well, and you can compare if you think it's easier. So 5 times 5 is 25. 5 times 1, or 1 times 5 is 5, plus 2 is 7. Now we're going to the 10, so we can put a 0 down here. 1 times 5 is 5. 1 times 1 is 1. Add this together. 5 plus 0 is 5. 7 plus 5 is 12. Carry the 1. 1 plus 1 is 2. So we've got 225. Now the alternative way we can do this is we can say, well, 15 times 15 is 15 times 10, so 10 15s, plus 5 15s. Okay, so it lets you just split it up. It's up to you if you prefer that way. It just means that then you can do the 15 times 10 is just going to be 150, and the 15 times 5 is slightly easier because now we've just got a single digit times a double digit. So 5 5s are 25, 1 times 5 is 5, plus 2 is 7. So you end up with 150 plus 75, which is exactly what we had there. Okay, so we've done the 15 times 15. Now we need to multiply it by the 6. So we've got our 225, multiply that by 6. Well, 5 6s. Well, we've got 6, 12, 18, 24, 30. Then we've got 6 times 2, or 2 times 6. 6 and 6 is 12, and 3 is 15. And then we've got 2 times 6 again, still 12. Add 1 this time is 13. So we've got 1,350, and that's going to be centimetres surface area, so it's going to be squared. Okay. Even though we're multiplying three things together, don't get it confused with volume. We're working out the area of one square, and then we've got 6 of them. So it's not that we're multiplying by another dimension. We are working out the flat surface area. Question 5. Simon is redesigning his garden. He has drawn his garden on the diagram below, where 1 square equals 1,500 millimetres. And they've shown us here. Okay, so we've got the length down this way, we've got the width this way. Using the grid, calculate the actual length of the garden in metres. Well, let's do it in squares first of all. So it's the length that we're interested in. Well, we got 1, 2, 3, 4, 5, 6, 7. And I think it's reasonable to assume this is a half. So we can say that this length, all the way down to the bottom, is 7.5 squares. Right. So what we need to do to this is we want 7.5. If each square is 1,500 millimetres, we need to multiply it by 1,500. So 7.5 times 1,500. We could do it using the column method. I'm going to split it into 2 bits. I'm going to say that this is equal to 7 times 1,500 plus 0.5, or a half, times 1,500. Okay, so we've got the 7 bit and the half bit. Well, if we want to do the 7 bit, we can do 7 times 1,500. 7 times 0 is 0, 7 times 0 is 0, 7 times 5, or 5 times 7. We've got 7, 14, 21, 28, 35. 1 times 7 is 7, plus a 3 is 10. So we've got 10,500. Now for the half, or 0.5 times 1,500. The reason I'm saying a half is because it might be easier to think of it as 1,500 divided by 2. So use the bus stop method. 2 into 1 doesn't go. 2 into 15. We've got 2, 4, 6, 8, 10, 12, 14. That's 7 times with 1 left over. How many times is 2 going to 10? 2, 4, 6, 8, 10. That's 5 times. and 2 into 0 goes 0 times. Right, so what we want is we want to add 10,500 with 750. Okay, I could have written this in a better place, but let's write the answer below. 0 plus 0 is 0, 0 plus 5 is 5, 5 plus 7 is 12, 2, carry the 1, put that here. 0 plus nothing is nothing, but we got the 1, so we can bring that down, and 1 plus nothing is 1. So we've got 11,250, and that's going to be millimetres. Okay, right, we want our answer to be in metres. Okay, well, instead of going straight to metres, which you can do, I'm going to say, well, I know that there are 10 millimetres in 1 centimetre. So if I just take the 0 off the end, in other words, divide by 10, I'm going to get that 11,250 millimetres. So I take 0 off, is going to be 1125 centimetres. 1, 2, 3, put the comma in there. So we've gone from millimetres to centimetres. Now I know that there's 100 centimetres in 1 metre, and it's metres that we want. So we want to divide it by 100 because we're making this smaller because there's going to be fewer metres than centimetres. So imagine our decimal points at the end. We've got 2 zeros, so we're going to move 1, 2. So we're going to get 11.25 metres. And we get a part B to this question. So this is 5B. Simon is planning to build a patio in his garden. The patio will have 4 sides. He has drawn a sketch of the patio below. And we're told the sketch is not drawn to scale. Put the measurements we've got are 6.6 metres across the top, 8.4 metres down at the bottom, and 4 metres this way here. And we can see we've got sort of a what's this? A trapezium, because we've got 4 sides, 2 parallel sides. Calculate the area of the patio. Well, you could split it up down here and work out the area of a rectangle and a triangle, but we already saw it was a trapezium. And hopefully you remember that the area of a trapezium has a formula which is a half times A plus B times H, where A and B are the parallel sides, so A and B, and H is the height, so this one over here. So in other words, it's going to be a half of 6.6 plus 8.4 times the height, which is 4. So the first thing we need to do is the bit in brackets. So 6.6 plus 8.4. 6 plus 4 is 10. Carry the 1. 6 plus 8 is 14, plus 1 is 15. So we've got a half times 15 times 4. Now, because we're multiplying these 3 things together, we can do them in whatever order we want. Well, I'm going to do half of 4 because it's an even number. It's easy to do half of it. And I know that half of 4 is 2. So in other words, we've got 2 times 15. And if I do this one over the side here, 2 times 5 is 10. And 2 times 1, or 1 times 2 is 2. Plus 1 is 3. So in other words, we've got 30 meters squared. Now we've got part C. For the foundation of the patio, Simon will use a dry mixture of sand and cement. He will need 20 kilograms of mixture for each square metre of patio. To make the mixture, he needs to mix sand and cement in the ratio of 5 to 1. So every time we've got 5 whatever, so 5 kilos of sand, we're going to need 1 kilo of cement. Calculate how many 25 kilogram bags of cement he will need. Show your calculations and the workings out here. So it's a ratio question. So I'm going to draw a ratio table. And we can start with the ratio they've given us, which is sand and cement. And we're going to have a total column as well. And the ratio of sand to cement is 5 to 1. And if that's all we had, well, 5 plus 1 would have a total of 6. Right. What we're actually trying to get to, we know that he's going to need 20 kilograms for each square metre of patio. If you remember from before, we had 30 metres squared. That was the total area. So what we need to do is we want 20 times 30. That's going to tell us how much we need in total. Okay, so we're using our answer to part B for here. So 30 metres squared, 20 kilograms for each metre squared, 20 times 30. We can do 2 times 3 is 6, and then put the 2 zeros on the end. Okay, so we saw that the starting point of our ratio, we actually need 600 kilograms, so we can write that down here. So we've got to say, well, how are we getting from this row up to this row? Well, to get from 6 to 600, we're just putting 2 zeros on the end. So in other words, we're multiplying by 100. So we need to do the same with these two. It's only cement we're interested in, but I'm going to do both anyway, because it's fairly straightforward when we multiply by 100. 5 times 100 is 500. 1 times 100 is 100. Okay, calculate how many 25 kilogram bags of cement we'll need. Well, we need 100 kilograms in total. So what we want is 100 divided by 25. Now, we're still not on the calculator section yet, so we've got to do this without one. Well, we can think, let's add them up. So if we had 25 and another 25, 5 plus 5 is 10. 2 plus 2 is 4, plus 1 is 5. So 2 25s would give us 50. Let's add another 25. 0 plus 5 is 5. 5 plus 2 is 7. Okay, well, let's keep going because we want to get up to 100. 5 plus 5 is 10. 7 plus 2 is 9. Plus 1 is 10. So we've got 1, 2, 3, 4. So we're going to need 4 bags. But I would hope that when you see something like 100 divided by 25, you're going to be thinking, well, 25% would be a quarter. So there's going to be 25%. So there's going to be 4 of these going into 100. So it's fine if you need to work it out this sort of way, but hopefully you'll be starting to notice some relationships between the numbers and be able to get some of these answers, or at least have an idea of what answer you're going to be expecting. So now we're going to start with the calculator section. Question 6. Khalid wants to buy a 2-bedroom house no further than 0.6 miles from the station. Khalid has saved a deposit of £4,875. He can afford a mortgage of 3.5 times his earnings, which is £28,145 per annum, or per year. The scatter graph shows information about the price and distance from the station of recent 2-bedroom house sales in the area. Can Khalid afford to buy a 2-bedroom house within 0.6 miles of the station? give a reason for your answer. And they tell us that 1 mile equals 1.6 kilometres. So what he's got is he's got this scatter diagram here where they've used actual house price sales, recent house price sales, and they've plotted them against the distance from the station. Okay, so for example, if we look at this house here, this point, it's 0.6 kilometres from the station and it costs £108,000. Right, so what we've got to do is we've got to work out whether with this amount of money, so this deposit and a mortgage of 3.5 times his salary, whether he can afford to buy a house which is 0.6 miles from the station or no further than 0.6 miles from the station. So we're going to start off by drawing a line of best fit because we want to use this information, but we can't use it at the moment because it's just points. So we're going to draw a line of best fit, which is a straight line, which goes straight through the data, following the overall pattern, so sloping down to the right. We want roughly the same number of points above the line as below it. We've got a couple more above than below maybe, but it's following the overall pattern. This looks reasonable. Okay, but what we can now do is use this to look at the price of house based on the distance from the station. Now, the only thing is on this scattered graph, it's got distances in kilometres, and at the moment, we've got our distance in miles. But we've got this conversion. If 1 mile is 1.6 kilometres, then 0.6 miles, well, we need to multiply that by 1.6 to get our answer in kilometres. So, 0.6 times 1.6 gives us 0.96 kilometres. So now we can use this to look up a value on our scatter graph. So where's 0.96 kilometres going to be? Well, 0.96 is going to be somewhere between 0.8 and 1. Well, we won't know right in the middle would be 0.9. So 0.96 is going to be somewhere along here, so slightly over halfway, so it's going to be around about here. 0.96. What we could do is just to a sort of approximation is we could use 1 kilometre here, okay, but I'm going to go with my 0.96 and I'm going to draw a line straight up to my line of best fit and then draw a horizontal line across. Okay, well, this is telling me that to get a house or a 2-bedroom house that's no more than 0.96 kilometres from the station, it's going to cost him something, well, this amount, which is somewhere between 104,000 and 106,000. Okay, we were not going to work out the exact amount for now. Might be a little bit tricky, but we're going to see whether we need that or if we've got enough with just what we've got here. What we need to compare it against is the amount of money that he's got to buy this house. And we know he's got a deposit of 4,875, and then he can afford a mortgage of 3.5 times his salary. So let's start off by working out what 3.5 times his salary is. So 3.5 times 28,145 is 98,507.5. So that's going to be 50 because that's pounds. Well, we want to add on the deposit as well. So we want to add on the 4,875. And this will give us the total amount he can afford, which is £103,382.50. Now, what you should be able to see is that 103,000 is going to be somewhere down here. 103,382. So in other words, it's going to be less than 104,000. We know that for sure. So what we can do is we can see, well, we know that the cost is going to be somewhere in this band, and the amount he's got is going to be in this band. So can Khalid afford to buy a 2-bedroom house within 0.6 miles of the station? We can say no. Now it does say give a reason. So this is the bit where we can say cost of house is between 104,000 to 106,000, and we can say Khalid can only afford 103,382. So it's showing it's less than what we got up there. Question 7. Find the mode in the following set of numbers. We've got lots of numbers out here. Well, I could sort them, which would be one way of doing it, but the mode is the number that occurs most often. So I'm just going to do it by observing. I'm going to start with my 8, and we've got 1, 8, we've got 2. So in fact, I'll put 8, and we've got 2 of those. 8.5, we've only got once, so let's cross these off once we've used them. 7, we've got a 7 and another 7. So 7, we've got 2 of them. So they could both be the mode, if that's the most we've got, 2 of each. Then 11, we've got 1, 11, 2, 11, 3, 11. So 11 occurs 3 times, so that's winning now. 23, we've only got once. 9, we've only got once. 7.5 I've only got once. So the mode, the one that occurs the most, is 11. Question 8. Calculate the median of the following set of numbers. Right. Now with these ones I am going to sort them. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8 numbers. Well, which is the smallest? 10. 9 is the smallest, so I'll give that a 1. Then 9.5. Then 10's going to be the next. Then 10.5. Then 11. Then 12. Then 15. Then 23. Now, doing it this way, I'm writing the numbers. If I get it wrong, if I realise, I haven't used all of them, I can cross them out and rearrange them. But by doing this, I've got my order set. Now I'm going to write them out. So number 1 was 9. Number 2 was 9.5. Number 3 is 10. Number 4 is 10.5. Number 5 is 11. Number 6 is 12. 7 was 15. These ones are in order now. And 23. So if we want to find the median, we're going to cross out the smallest and the largest. And we keep going, doing it in pairs until we're left with 1, or in this case, 2 in the middle. When we have 2 left, because it's an even number of observations, we're going to have 2 left. We're going to add them together and divide them by 2 to give us our median. So we've got 10.5 plus 11 equals, divided by 2, 10.75, which is halfway between 10.5 and 11. Question 9. Amy wants to catch the 10:12 a.m. train from Darlington to Chesterfield. She needs to allow 10 minutes to buy a ticket and get to the platform. She lives 2 miles from the station and knows that she can walk at 3 miles per hour. At what time should she leave home? Right. Well, let's start off by working backwards. If she wants to catch the 10:12 train, she needs 10 minutes to buy a ticket. So let's take off 10 minutes. In fact, I'm going to do it 2 dots there to make it clear it's not decimals. Well, 12 minus 10, you can use your calculator, but that's going to leave you with 02. So it's going to be 10:02 a.m. That's before she buys the ticket. Now, she lives 2 miles from the station and she can walk at 3 miles per hour. Okay, well, there's 60 minutes in an hour. So if we do 60 divided by 3, this is going to tell us how long it takes to walk 1 mile. So 60 divided by 3, 20 minutes. So 20 minutes for 1 mile. She walks she lives 2 miles from the station. So 2 times 20 is going to be 40 minutes. So we want to work backwards. So we've got our 10:02. We want to take off 40 minutes. Okay, this is the bit where it can get a little bit trickier. We kind of got to try and take this off. Well, first of all, let's think, well, let's just take 2 minutes off. Okay, instead of doing 40 in one go, if we just take 2 minutes off, that would take us back to 10 o'clock. Okay, well, if we've used up 2 of that, we can do 40 minus 2. So that means we've still got 38 minutes to take off. Now, if it's 10 o'clock, if we're taking 38 minutes off, it's part of an hour. So we're definitely going to go back to 9 something. Okay, but it's not going to be 100 take away 38 because we've only got 60 minutes in an hour. So what we need really is to start with a full hour, which is 60 minutes, take away the 30, which takes us back to 9:22 a.m. Question 10. Tom is given £8,500 to go towards a deposit to buy his first house. Tom sees these 2 savings accounts. We've got the money saver account, 1.75% per year, to be added at the end of each year. So we assume this is talking about interest. The bonus saver account, save for 3 years and receive a single bonus of 5.25%. Tom puts his money in the money saver account, so this one. How much more money will Tom have after 3 years compared to the bonus saver account? Right, so what we've got to do with this one, they don't make it explicit, but we're going to assume that this is 1.75% compound interest. So in other words, if you earn interest in the first year, in the second year, you earn interest on that interest. So in other words, what that means is we start with £8,500. After 1 year, it's increased by, and what we need to do is to turn this, if this is 1.75%, we want to add on 100. So add on 100%, which would give us 101.75%. Now we need to turn this into a decimal so we can multiply it. So if you were increasing something by 5%, that would be like multiplying it by 1.05. Because 0.05 would be your 5%, but you're not just working out the 5%, you're adding on the original bit, the 100%. So this is your compound interest formula, really. So what it's saying, if this is percent, if we want to do it as a decimal, we need to divide it by 100, which means moving that decimal point back there. So 101.75 divided by 100. So instead of a percent, we now got it as a decimal. So we're multiplying it by 1.0175. So the 1 is the 100%. This is, we're keeping the amount we're starting with, and then we're adding on 1.75%. So we're going to multiply it by 1.0175. That's to get us to the end of the first year. Multiply it by 1.0175 to get us to the end of the second year. And same again to get us to the end of the third year. So 8,500 times 1.0175. Let's say if you want to think of it as 8,500 and you're multiplying it by 101.75%, so then divide it by 100. That's still going to work out okay. That's for the first year. For the second year, you do the same thing again. So I'm just going to go straight with the decimal version of it. So timesing it by 1.0175. That gets us the value at the end of the second year. Multiply it by the same again to give the value at the end of the third year. So that is £8,954. And because it's money, we want two decimal places, so 10. 4 is less than 5, so we can just keep it as 0.10 or £10. So £8,954, 10 pence. Sorry, 10 pence, not pounds. Now, what about if we use this one? Well, let's just save it for 3 years and receive a single bonus of £5.25%. Let's work out that bonus. So that would be 5.25 divided by 100 times the 8,500. Okay. This will probably make a bit more sense this way because I'm working out the bonus separately. I could do it in one go, but so this is our 5.25% as a decimal. Then we multiply it by 8,500 to get £446.25. That's just the bonus bit. So we need to add on the original 8,500, which gives us £8,946.25. Said how much more will Tom have from this account compared to this one? So we want £8,954.10 minus £8,946.25. 8,954.10 minus 8,946.25. £7.85. Question 11. The formula below is used to calculate the percentage fuel saving when driving at a reduced speed compared to a higher speed. So we've got F equals 100 times A minus B, all divided by B. All of that is worked out and then squared. Where F equals the percentage fuel savings, A equals the original average speed, and B is the reduced average speed. Calculate F when the speed is reduced from 60 miles per hour to 50 miles per hour. Show your calculations and the workings out below. So we're just going to put these values into our formula. So the 100 stays the same, and the multiply. The A is the original speed, which is 60. Subtracting the reduced speed, which is 50. And all of that is then divided by 50. And we're working all of that out before we square it. Okay, so we want to work out this bit in brackets. So we're going to keep the 100. And it's still going to be multiplied by something. But what's that something? Well, it's going to be 60 minus 50, which is 10. And then we might as well divide that by the 50. So we've got 0.2. Now remember that answer, the 0.2, is then going to be squared. Well, so let's do that. So 0.2 squared, so 0.2 times 0.2 is 0.04. Times it by the 100. And we get an answer of 4. And they told us that that's percent. And there we go, nice and straightforward. Question 12. Rahima is concerned about the environment and is looking for ways to be more eco-friendly. Rahima is researching the use of solar panels for her house. She has found some information on the total number of sun hours per month where she lives for 2016 and 2017. So let's have a look at this. Total sun hours per month. So for January 2016 there were 21 sun hours, 2017 there were 47. So we've got the numbers for all of the months. We haven't got the December 2017 yet. But they tell us the average sun hours per month in 2017, we've got a mean of 94.5. So that's the mean of the whole year. Rahima thinks the total number of sun hours was higher in December 2017 than in December 2016. Is she correct? Well, let's think about it. Well, the mean is the total divided by the frequency. Okay. Well, we've got the mean. They've told us it's 94.5. And the total, well, we haven't got the full total, but maybe we can work out the total of these 11 months and see if we can use that. Well, we've got 47 plus 61 plus 119 plus 128 plus 214 plus 108 plus 144 plus 126 plus 94 plus 56 plus 6. So our total is 1,103, but we've got to add on the December value. We don't know what that is yet. And then the frequency, well, that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, but actually 12 months. It's just we don't know what the December one is. So in other words, we're trying to work out this value. So we need to do a bit of rearranging to work out what this is for December. Well, if we're dividing this total by 12, we want to find out what this is. So maybe if we do the opposite of dividing by 12 and multiply by 12. So if we do 94.5 times 12, we can say, well, this number before you divide it by 12 is going to be 1,134 is equal to 1,103 plus the December value. Well, if we want to find out what the December value is, all we need to do is take this number away from here. So we want 1,134 minus 1,103, which gives us 31. Okay. Well, if this is 31, Rahima thinks the total number of sun hours was higher in December 2017 than in December 2016. Yes, 31 is higher than 21. So is she correct? Yes, she is. Part B. Which year had the greatest range of sun hours? Okay, well, let's go back to our numbers. For the range, we want the biggest minus the smallest. So in 2016, what's the biggest? 206. That looks like the biggest number. And what's the smallest number? 21? Anything smaller than 21? No, we've got two 21s. So let's do this. So range for 2016 is going to be 206 minus 21, which gives us 185. Now the range for 2017, well, what's the biggest value in 2017? 214, yeah. And the smallest, we've got 6 down here. So we want 214 minus 6, which gives us 208. Okay. Now let's go to the actual question again. Which year had the greatest range of sun hours? So that was 2017. And we've got our workings over the page. Question 12, part C. And if you printed this out, be careful because part C is at the bottom of one page. There's an important bit that starts here before we move on to the rest of the question. To generate the maximum amount of electricity, a solar panel needs to face south and to have a tilt angle of 30 degrees. This will generate a maximum of 1.225 kilowatt hours of electricity for each hour of sunshine. In June, there were 108 hours of sunshine. Now, this is where the question goes over the page. We're told Rahima's roof faces southwest and has a tilt angle of 50 degrees. To find out how much electricity her solar panel will produce, she needs to divide the maximum electricity that could be generated by a factor given in the table below. Well, we were told that that maximum on the previous bit was 1.225. So we need to divide that by a factor. Now, what factor? Well, her roof faces southwest. So facing southwest, it's going to be one of these. And it's got a tilt angle of 50 degrees. So it's going to be this one here, where they cross. So it's the 1.225 divided by the 1.09. So 1.225 divided by 1.09, and we get this 1.1238532. Okay, but I'm going to keep that in my calculator for now. So that's what we've got to use, but then that's per hour. Now they told us that in June there are 108 hours of sunshine, so we need to multiply that by 108, and excuse me, we're told here that she usually pays 0.143 per kilowatt hour. So in other words, that's the number of hours. We then multiply that by 0.143. So we've still got this in our calculator from before. Multiply it by 108. Multiply it by 0.143. And we get 17.35. But we want two decimal places, so we look at the digit afterwards. It's more than 5, so we're going to round up that to 36. So we've got £17.36. So we took the factor that they gave us, we adjusted it by the factor that we've looked up, we've then multiplied it by the number of hours in June, and then also multiplied it by the cost, or how much, the cost per kilowatt hour, to give us this total here. Question 12, part D. Rahima finds that she can be more environmentally friendly by collecting rainwater from her drain pipe, so she can use it to water her garden. Rahima buys a cylindrical container that is 80 centimetres in diameter and 1 metre high. So let's draw that. So it's going to be cylinder, something like this. And we're told that the diameter is 80 centimetres. So that's distance from end, side to side, going through the centre. Okay, and we've got 1 metre high. Now Rahima thinks the container will hold at least 100 gallons of water. Is she correct? And we're told that pi equals 3.14 and 1 metre cubed equals 219.97 gallons. So what we need to do is work out the volume of this cylinder. Okay. Well, if we want to work out the volume, first thing we need to do is work out the area of the circle. And the area, and then we can multiply that by the height. And the area is pi r squared, where r is the radius. Okay, well, the radius is the diameter divided by 2. And we've got the radius, or the diameter here is 80, so 80 divided by 2. So that's 40 centimetres. Now, our conversion is for metres cubed. So what we're going to need to do is to change these centimetres into metres. Well, I know that there's 100 centimetres in 1 metre. So we're going to need to divide this by 100 to turn it into metres. So 40 divided by 100 is 0.4 of a metre. So now when we put this in our formula, we've got pi, which they've told us is 3.14, times the radius in metres, which is 0.4, and it's squared, so we multiply it by itself. So 3.14 times 0.4 times 0.4, which gives us 0.5024 metres, and that's going to be squared because it's the area, but then we're going to multiply it by 1 metre, so we can just say the volume is going to be 0.5024 times 1 because we're multiplying it by the height. So the number's going to stay the same, but the units are now in metres cubed because it's now volume instead of area. Okay. Right, now we can use our conversion. So if 1 metre cubed is 219.97 gallons, well, we need to multiply 0.5024 by 219.97, and this is going to tell us how many gallons. We get 110 point, I'll do it to 2 decimal places, 0.51. Well, that is greater than 100, and that's all that we're interested in. So is she correct? Yes, she is. Okay. Question 13. We've got the X and Y axis here, and they ask us, on the grid, mark the point 4, 2. So we always go on the x-axis first, so we go across to 4, 2, so we go up to 2. Oh, it's not great, but that's what we wanted there. And we can even write the coordinates as well. We don't have to, we can just put our cross. There we go. Question 14. Give 144 as a fraction of 240 in its simplest form. Show your calculations and our workings out here. So 144 as a fraction of 240. Well, I'm just going to do this. It might not be the most efficient way, but they're both even numbers, so I'm going to divide them both by 2. So 144 divided by 2 is 72. And 240 divided by 2 is 120. Well, they're still both even numbers, so we can divide them both by 2 again. And it should make these numbers easy to manage as they get smaller. So 72 divided by 2 is 36. And 120 divided by 2 is 60. They're still both even, so let's divide them by 2 again. So 36 divided by 2, we'll get 18. And 60 divided by 2, 30. Still even, so we can still divide them both by 2. 18 divided by 2 is 9. 30 divided by 2 is 15. They're not both even anymore, but are there any other numbers that can go into them? Well, if 2 doesn't work, try with 3. What about if we divide them both by 3? And we've got our calculator, so it's easy to check. 9 divided by 3 goes 3 times. And 15 divided by 3 goes 5 times. And we're not going to be able to get any smaller than that. You can't find any number that goes into 3 and 5 other than 1, which isn't going to help us get it any smaller. Question 15. Sarah helps to organise a family fun day charity event each year. Last year, 120 people attended the event, each paying a £2.50 entry fee. And we've got the money taken during the event, which is blank for all of them. The percentage of money taken and we've got it split by the different things: so entry fees, cake stall, bouncy castle, tombola, and wheel of fortune. It costs £175 to hire the village hall for the event and a further £85 for prizes. How much profit did Sarah make for charity? Right, so let's think about how much money did they take to start with. Well, we had 120 people, each paying £2.50. Which is a total of £300. So we can put that in for our entry fees. Now what we can do is work out what percentage this is, because we know that the total percentage must be 100%. So if we add these up, take them away from 100, that's going to tell us what percentage the entry fee must be. And from that, we can work out the other values. So let's add these ones up. So we've got 19 plus 32 plus 9 plus 15. So these four total 75%. So this missing bit, well, it must be 100 minus 75, which gives us 25%. Well, if 25% is £300, we want to work out how much money 1% would be. So we can say 300 divided by 25. So that's £12, and that represents 1% of the takings. So all we've got to do, if we want to know how much money was made from the cake stall, if we know that was 19%, well, £12 is 1%, so it's just going to be the 12 times 19. So £228. For the bouncy castle, 32%, so it's going to be 32 times 12, which is 384. The tombola, that's going to be 9 times 12, which is 108. And the wheel of fortune, well, that's going to be 15%, which is £12 per percent, £180. Okay. Well, they're asking how much profit Sarah made. Well, how much money did she take in total, first of all? So let's add these all up. So we've got 300 plus 228 for the cakes, £384 for the bouncy castle, £108 for the tombola, and £180 for the wheel of fortune. So a total of £1,200. So we need to take off any costs. So we've got 1,200, and we're going to take off, well, the costs are down here. It was £175 for the hall and £85 for the prizes. So we'll add those together and take those off in one go. So in other words, it's going to be 1,200 minus 175 plus 85 gives us 260. So 1,200 minus those total costs leaves us with £940 profit. (15b). Sarah bakes 15 identical cakes for the charity event. Each cake is circular with a radius of 80mm. She plans to decorate each cake with a piece of ribbon around its edge. She wants to buy an extra 12.5% to allow for overlap. She can only buy ribbon in full metres, costing £4.95p per metre. How much will she spend on ribbon? Use pi equals 3.14. Okay, so let's think about these cakes. They're circular with a radius of 80mm. Now, the ribbon needs to go around the outside. So in other words, we want to find out what the circumference is. And the circumference is worked out by 2 pi r. So in other words, it's 2 times pi, which is 3.14, times r, which is 80 millimeters. Now, I'm going to keep it in millimeters for now, and then I'm going to convert it afterwards. So if we multiply this all out, 2 times 3.14 times 80 is 502.4 millimeters. That's for one cake. We've got 15 cakes, so we're going to times that by 15. So that's 7,536 millimeters, and I'm going to put 15 cakes. Now we've got to think about the overlap. It's 12.5%. Now I'm going to work out the 12.5% and then add it on. So we're going to say, so it's 12.5%, so in other words 12.5 divided by 100 of, which is times, 7,536. So this is just working out the overlap bit. So 12.5 divided by 100 times 7,536. So it's going to be 942 millimeters for the overlap. So the total ribbon is going to be 7,536 plus 942, which is 8,478 millimeters. Right, we want to get it into meters because the cost is per meter. Well, we've got 10 millimeters in 1 centimeter. So again, I always like to go to centimeters first. You can go straight to meters, but I find this easier. So if we divide this by 10, we get 8,478.8 centimeters. And we've got 100 centimeters in 1 meter. So if we divide this by 100, we get 8.478 meters. Now, she can only buy ribbon in full meters. So even though we want 8.478, we're going to have to buy 9 meters. Because 8 won't be enough. So we've got to buy that 9th one as well. So 9 meters, costing £4.95 per meter. Gives us a total of £44.55p. And finally, part C. At the charity event, there is a Wheel of Fortune game for the boys and girls. To win, you need to spin the dial and land on a win segment. So one of these green ones. Let's put it down so we can, that's it, see that. 15 girls and 15 boys are each having a turn on the game today. What is the probability today that a child who plays is a girl and that she wins a prize? Well, let's think about this probability of winning a prize first of all. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 segments. And 1, 2, 3, 4 of them are wins. Okay, so on the probability that it's a child is a girl, well, we've got 15 girls and 15 boys. So you can think, well, it's 15 out of 30. But basically, we've got the same number of girls and boys. So the probability that it's a girl is just a half. And the probability that the person wins is 4/12. So if we want the probability of both, the probability that it's a girl, which is a half, and the probability that it wins a prize, it's going to be a half times 4/12. So 1 times 4 is 4. 2 times 12, you can use a calculator, but it's going to give us 24. Now we can simplify this. We don't have to simplify it because they haven't asked us to, but I would anyway. We can divide both by 2 because they're both even numbers. So if we do 4 divided by 2, we get 2. And 24 divided by 2 is 12. They're both even still, so dividing by 2 again. 2 divided by 2 is of course 1. 12 divided by 2 is 6. So my answer is 1/6. And that's the end of the paper. So I hope you found it helpful. It's a very difficult paper. Although this is still level 2, I do find that this the Open Awards paper is quite challenging, but manageable. You just got to work through it carefully, think of all those facts that you know, apply it step by step. So hope you like the video, subscribe to the channel, make sure your notifications are turned on, and look forward to seeing you again soon. Thank you.